In this problem, we're wanting to graph tangent. Graphing tangent is similar to graphing the other four trig functions. So we're going to follow those same steps. We're just going to tweak some things. So first of all, we're finding the period. And since tangent finishes its cycle within a distance of pi units, the period is we're going to use pi over absolute b as our formula. So the coefficient in front of our x is 4, so that's going to become pi over absolute value of 4, which is pi over 4. And as we did before, we're going to divide the period by 4, or alternately multiply by 1/4. I'm going to just multiply this by 1/4, and I get pi over 16. So that means my x values are 0, pi over 16, 2 pi over 16s, 3 pi over 16s, and 4 pi over 16s. Now we'll go to the next slide and continue. Now we're going to find the y values for tangent. So the y values, if you think of tangent as sine over cosine, you can figure out that at 0 and at pi, you're going to get 0 for tangent, and at 90, you're going to get undefined. And then if you take 180 and divide it by 4, you'll get 45. So note, we are dividing our period by 4. So when I find the tangent of 45, I get 1, and then the tangent of 3 45s or 135 is going to be -1 because we're in quadrant 2. And so those are my y values for tangent. And as we've done in the other graphing problems, we're multiplying our y values by our a, which in this case is -2. So when we multiply that through, our y values become 0, -2, undefined, 2, 0. And when we bring the x values over, we had 0 pi over 16, 2 pi over 16, then we had 3 pi over 16s, and 4 pi over 16s. And so when we graph that, we're going to graph the point 0, 0, and we're going to graph the point pi over 16, -2, then the undefined is a vertical asymptote, then we're going to graph 3 pi over 16, +2, and then we're going to graph 4 pi over 16, 0. Now, remembering that tangent is x cubed graphs, I like to start at the x-intercepts, pass through the other point that I drew, and head toward the asymptote to form an x cubed looking graph. So I'm going to go to this other x-intercept, travel through my point, head toward my asymptote. So there is one period, since I have the bottom half and the top half of an x cubed graph. And if I needed 2 periods, then I could finish this x cubed graph off and then add in an asymptote. And then over here, I can finish that x cubed graph off and add in my asymptote. And so then I would have 2 full periods. And this one has to go over a little bit. So that would be the graph of tangent where you'd have 2 periods.